Okay, here's where things start getting fun. So today's lesson is going to be kind of extending on what we just learned about these straight chained alkanes. And now it's like, what do we do if we're going to take an alkane and maybe make some branches for it? Meaning I can see stuff coming off of carbons within the chain that do not include the carbons being bonded to the other carbons in the chain. Okay, I've got something else going on here. And in fact, if you want to look on the back page of what, oh my goodness, what is she having us do today? This is super fun and it is not as challenging as what this looks like. Okay, we're going to walk through it, do lots of practice examples, and you guys are going to leave here being like, oh my gosh, I can name some really fun things. And yay. Okay, so yeah, we're going to be using our highlighter a lot today. Highlighter and pencil. Here we go. We are ready to go. Here's some steps for naming these branched alkanes. And just as a review, alkanes are carbons that are single bonded to each other in that carbon chain, okay? Which is in fact what I see. I see only one line, so those are my alkanes. It says, find the longest continuous chain of carbon. It does not have to be in a straight line. That means it could potentially go down or could go up through a different branch. I've got to find the longest connection of carbons in a row, okay? This is going to be called the parent chain. And your entire name of the alkane is going to be determined by the number of carbons in that parent chain. So we're going to get out our highlighter. This is the structure I've given us to name. Now, I'm going to go through some options here. We're going to see where's the longest possible continuous chain I can count of carbons to give me that parent chain. Here we go. Let's go 1, 2, 3, 4. So looking at those guys, that's 4 in a row. I could also go 1, 2, 3, 4. Those are the same. Is there another option of a chain that I can find? Sure, I can go this way. 1, 2, 3. So that's definitely not it. So now I have two possibilities of the longest chain, both being 4. It does not matter which one you pick because the naming will be the same, I promise. So let's go ahead and just since this is our first example, let's not do anything a little bit too visually freaky. Let's do, yep, there's our parent chain. So we've highlighted our parent chain. It says the longest continuous chain of carbon atoms will contain 4 atoms. Okay, it says state the number of carbon atoms using the appropriate prefix and the ending -ane because these are single bonded carbon alkanes. Okay, so let's think here. I've got 1, 2, 3, 4 in my parent chain. We know that 4 carbons equals bute, right? And we know that they are all single bonded together, right? So all single bonds, which means that will be ending in -ane, right? Put those together, we get butane. Yay! But I can't just call it butane because plain old butane would have nothing branched off of it. It would just be a straight chain, right? So I gotta kind of specify well, there's some a little bit extra going on here. Okay, so the next step, it says you're going to actually number the carbons on the parent chain according to your special groups. Well, here's my parent chain. And now she's wanting me to like 1, 2, 3, 4 or 1, 2, 3, 4. It's going to be according to, say hello to a special group. Hi, special group. This special group or this branching is called an alkyl group. So this is an alkyl group, okay? I'm going to number my carbons in my parent chain starting at the end that is closest to this alkyl group. Well, the carbon that is closest to my first branch is that guy. So that's my carbon number 1. So 1, 2, 3, 4. So now I've established a numbering system. I'm actually going to use this numbering system to let you know on which carbon some of these cool branch things are on, which is really fun. Okay, it says locate and name your branched groups. So let's go back and repeat what we have drawn here. I'm actually going to go back. This is an alkyl group. Yes, it's an alkyl, but we're going to write an alkyl group. Okay, so there's my parent chain. We said that this was carbon 1, this was carbon 2, this was carbon 3, and this was carbon 4. And now I'm going to figure out, well, what do I actually name this alkyl group? Because an alkyl group can be many different looking things, okay? It says, identify the location of my alkyl group according to the parent chain that it branches off of. He's off of carbon 2, right? Each alkyl group has a prefix according to the number of carbon atoms in that alkyl group, okay? My branch names will end in -yle instead of -ane, and your alkyl groups with 1 carbon will be methyl. 2 carbons would be ethyl. 3 carbons would be propyl. You were like, oh my gosh, that was a lot of words. Okay, let's break this down here. This is my first, or my only alkyl group that I need to name. The first thing I need to ask you is how many carbons are in that branched alkyl group? It's 1. What's the prefix for 1 in organic chemistry? Me eat peanut butter, so that prefix for 1 is meth. So we're going to say 1 carbon. And so that means we are meth. This is not methane. The ane would be for the specific parent chain of an alkane here. I got something underneath my page that's making my pencil bump all over the place. This is a group. This is an alkyl group with, yes, 1 carbon. So we're going to say this is a methyl or a methyl group. So I have 1 carbon. So I got a methyl group. Yay, I have a methyl group. I've named the group. Now, if this had C2H, what it would be, H6, then that would be an ethyl group. If this was C3H8, meaning 3 carbons, would be a propyl group. We could have a butyl group. We could have a pentyl group. Okay, so the length of the carbons on that chain or on that branch is going to name, you're going to name it accordingly like this. Okay, so I've got 1 carbon, methyl, right? And that methyl group is on the 2nd carbon in the parent chain. So I'm going to say on 2nd carbon. So I've got this information, okay? So now I can name this group as a 2-methyl group. I have now, with this naming system, identified, well, what is that branch look like? Well, he's methyl, so he looks like this. And on what carbon in the parent chain he is on, that is a 2-methyl group. All right, now I'm ready to piece this together. Y'all, we got, oh my gosh, look at this. We got a butane, and now we got a 2-methyl. Now we're going to put these things together, and we can name this branch alkane. It says you're going to state the name of the alkane by naming each one of the branches and then naming the parent. You'll use commas between numbers and hyphens between numbers and branches. You're like, we're going to ignore that last sentence for now. We'll kind of walk through what that last sentence means when we go through over the more complicated examples on the back page. So that was my parent chain, right? We had a 1, 2, 3, 4. Here was my alkyl group, which we said is a methyl group, which is on the 2nd carbon in the parent chain. So we have a 2-methyl butane. The name of this structure is 2-methyl butane. So I get to write whatever the branch groups are in front of my name for the chain alkane, the butane. Okay, so let's do some more fun examples here. This is going to be great. Flip to the back. I'm excited now. All right, so the key thing on each one of these practice problems is I'm first going to find the parent chain, which is the longest continuous chain of my carbon atoms. It may not be in a straight line, so you may have to travel to all of the places to figure out what is the longest continuous counting of carbons that you can get. Okay, so in fact, if I went straight across, I would only get 1, 2, 3, 4, 5. That's 5. Let's keep that in mind. 1, 2, 3, 4, 5, 6. Uh-oh, that's got longer. We still have some more options. 1, 2, 3, 4, 5, 6. That is an option too. 1, 2, 3, 4, 5. Okay, so it looks like we can either go 6 this way or we can go 6 this way. Okay, like I said before, it does not matter. If you have 2 parent chains that are the same amount, the naming will actually work out. That was actually our first category. In fact, let's flip back to the first page. I keep doing a lot of flipping. That is okay. If I decided that this was my parent chain, that was fine. this would be my carbon 1, carbon 2, carbon 3, carbon 4. And that would be my methyl group. The methyl group would still be coming off of the 1, 2, second carbon. So the name would totally be the same. So you got to trust me on this. All right. So let's just make 1, 2, 3, 4, 5, 6. That 6 chain, our parent chain. This is where the highlighter really helps out. We're going to highlight our parent chain. We love this. Yep. And now I have to number these carbons. I'm going to number these carbons to where the first branched group is closest to carbon number 1. So if I use this as carbon number 1, I see my first branches, and I got 2 of them. Do not freak out. We will get there. 1, 2, 3. If I started carbon 1 right here, my first branch groups would be on the number 3. Well, what about if I started over here? 1, 2, 3, 4. So that has to be carbon number 1 because my branches happen the earliest if I start my numbering system over on him. So I'm going to number my carbons. Cool, 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 cool. All right. So I can even now, like this is a 1, 2, 3, 4, 5, 6 hexane. Hexane. This is something, something, something hexane. We know that we will be writing. Well, what is this something, something? Well, let's circle what branches we have. We got this guy coming off in this direction. That's a branch, like a tree branch. And we got this guy. So we actually have 2 branches. And if you're looking, the branches, thank goodness they did not write all of those individual hydrogens. They're showing these structural formulas to where they're like, here's a carbon and here's how many hydrogens are in it, and here's another carbon showing how many hydrogens are in it. Okay, but like we mentioned before, when I'm naming these alkyl groups, I gotta figure out how many carbons are in that branch group. Well, this one's got 2. Me, eat, peanut butter. Me, eat, eat. So the prefix for 2 is eth, and this is an alkyl group, so this is an ethyl group, right? We also have another ethyl group here. We got 2 ethyl groups. Whoa, this is wackadoo. You guys, I skipped over this. It says if multiple branches on the front page have the same number of carbon atoms, use the prefix di. Yeah, I got 2 ethyl groups, so I got diethyl. If I have 3 ethyl groups somewhere in this structure, I'm going to use triethyl. If I got 4 ethyl groups all in this structure, I'm going to use tetra, blah, blah, blah. And if there are different alkyl groups, we are going to put them in alphabetical order. We do not have different types on this example, but I did want to mention that since I have 2 ethyl groups, I'm going to be looking at a diethyl naming situation. Now, just like in our example on the first page, I have to tell you where these branches are, on what carbon in the parent chain they will be branched off from. Well, let's see. Well, the 3rd carbon. And both of the ethyl groups are coming off of the 3rd carbon. So the locations for these ethyl groups are on the 3rd carbon, and the other one's also on the 3rd carbon. And then I'm going to name those alkyl groups, and there are 2 of them, 2 ethyl groups, so diethyl, right? This is telling me that 2 ethyl groups are coming off of the 3rd carbon, 1 here and 1 here, yes? And then my name of my parent chain, since that's all the branches I got here, is my hexane, 3,3-diethyl hexane, yep. So this tells me that there are 2 ethyl groups, and these tell me where the location of those 2 ethyl groups are. Great. Okay, here we go. We're getting excited now. Oh, a little bit different. Some of the lines have been taken away. That is okay. Follow your C's, okay? Longest continuous parent chain. Let's see. 1, 2, 3, 4, 5, 6. All right, 5. 1, 2, 3, 4, 5 carbons there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We got a lot of 5s. I think a lot of our journeys are 5, but since I'm like, I got lots of possibilities, let's pick maybe the one that is maybe looks the simplest to our brains. Now I'm going to number. I'm going to start carbon number 1 at the end where the closest branch groups are. That looks like definitely on this end. Well, let's see. It looks like this, if I started on this way, I got carbon 1 here, and this would be carbon 2, and I see a branch. And sometimes it helps to visualize and circle your branches a little bit better. So, oh, I got a branch on carbon number 2 if I went this way, 1, 2, 3, 4, 5. But what if I start this way? 1, 2. I got branches also coming off of carbon 2. So my first branches, no matter which way I name it, are on carbon 2. How do I choose? Well, who of those carbon 2 possibilities has the most branches? Is this guy right here. Okay, so we're going to say, just since this is for our notes page, we're going to say more alkyl groups here. More alkyl groups here. Okay, so that means I'm going to be naming this guy carbon 1. This guy will be carbon 2. It's hard to see. This guy will be carbon 3. This guy will be carbon 4. And this guy will be carbon 5. Awesome. Now I'm ready to start naming. I know this is a 5 carbon parent chain, so this is a pentane. So what alkyl groups do I have here? It looks like I have, this is a 1 carbon methyl group, another methyl group, and another methyl group. They all the same. They're all methyl groups. I got 3 of them. So I got a trimethyl naming situation. Well, I got to give you some numbers telling you, well, where each one of these 3 methyl groups are on those parent chain guys. Well, I got a 2 methyl group, I got another 2 methyl group, and I got a 4 methyl group. So we're going to give all of those numbers showing the location of all of those carbons where the methyl groups are coming off of, right? So 2,2,4, tri-methyl, and then pentane. Yeah? Very cool, very exciting. Okay, let's see. Next one. Ooh, we got lots of chains to kind of start tackling here. This is going to be very fun. Okay, so I go 1, 2, 3, 4, 5, 6, 7, 8. That's a possibility. 1, 2, 3, 4, 5, 6, 7, 8. That's a possibility. 1, 2, 3, 4, 5, 6, 7. Okay, but we're also starting to look here, and I probably should have mentioned this on the previous example. Actually, the previous example it did not apply to. So I can either go this way to get 8, right? Or I can go this way to get 8. I probably, on this situation, since there's lots of branching problems, if I chose 8 this way, then I would have this as a branch. And then I would, y'all, what is going on here? I've got a branch that has more branches on it, okay? That becomes way more complicated. So if there's an option for you to pick a parent chain when you're deciding, well, which one do I pick? They both have the same number of carbons. Pick the one where you do not have a branch on a branch situation. I will not give you a branch on a branch situation to have to name. That sounds terrible. So we will pick the 8 carbons in a row where I will only have branch groups that do not have continuous branches off of them. Okay, so I go like this. All right, those are my 8 carbons, so we know that we have an octane situation here. So I'm going to number my carbon atoms to where carbon number 1 is closest to the first branch group. So let's see here. I like to circle my branch groups. That makes it easier for me. Cool. And I can see I've got a 1, 2, 3, a propyl group, another propyl group, and an ethyl group coming in here. Okay. So if I start this as carbon number 1, 1, 2, 3, 4. My first branch comes off of 4. Okay, if I start this as carbon number 1, 1, 2, 3. Now my first branch comes off of 3. So I'm going to pick the one that's closest. 1, 2, 3, 4, 5, 6, 7, 8. So this is the first time that we've had branch groups that were not all the same. In this first example, both of our branches were ethyls. Both of our branches all 3 of our branches were ethyls. Now here I've got 2 propyls. I got some dipropyl going on here, and I have an ethyl. Who do I name first? You're going to name the different branch groups alphabetically. So we're going to write alphabetical. All right, so that means if I've got ethyl, and I've got propyl, E comes before P in the alphabet, so I'm going to be naming the ethyl part first. Okay, so my ethyl group, and I only have one ethyl group in this structure, is I've got an ethyl group on carbon 3, so I'm going to come in first with 3 ethyl. But then I got some more alkyl groups to name. So I'm going to put a dash. And if this was all one line, if I were not running out of space, I would totally make this a continuous line, but this is super fine. We're going to drop down and we got to tackle the other alkyl groups that are on here. Well, we got propyl going on here, right? And there are two of them, so dipropyl, and they are on the 4th and 5th carbon. So I would then say 4, 5 dipropyl. And then we're done with all of our branches. We're going to name what that root alkane is, octane. Octane, running out of room, octane. So this is a 3-ethyl 4,5-dipropyl octane. So the purpose of this example is showing that alphabetical, right? And I do not mean alphabetical including the prefixes. I mean alphabetical including whatever the prefix of the prefix, including whatever the me eat peanut butter is. So the ethyl comes before propyl, so I would be representing that guy first. Okay, got a few more examples. This is getting fun. All right, okay, yes. All right, longest continuous parent chain. It looks like if I go 1, 2, 3, 4, 5 this way, but if I picked this 5, I can already see that one of my branches would be a branch upon a branch situation, which I'm like, hopefully there's a better option for me, which in my little unit, which is an intro, there will be. So let's see if we can find him. We can go 1, 2, 3, 4, 5. That could work. It doesn't give me any weird branches on branches. Or I could go 1, 2, 3, 4, 5. Same thing. Both of these are an option for you. I don't know. I don't want to do too much ziggy-zaggy unless I absolutely have to. So let's just go straight on down and say that that's my parent chain. Okay, I like to circle my branch groups, my alkyl groups. And now over here, I can see that this CH3 is a branch coming off of here. You kind of wish that they would put a dash in here, but they did not, and that is fine. We know how to read. We know what a condensed structural formula is telling us here, right? So this carbon guy is a branched carbon. It looks like they're all the same type of a branch. They're all a 1 carbon containing branch, which is a methyl group, right? So we got some methyl groups here to look at. Picking carbon number 1. So if I started here, 1, 2 is where I see my first branch. We love that, right? If I started here, I see 1, 2. Uh-oh. Okay, well, they're both 2, and both of those potential 2 options have only 1 branch, and they are the same. Okay, well then, is there something closer to the carbon number 1 if I established a system on either end? Oh, the next guy is here. So that would be if I had carbon 1, 2, 3, I would get another branch on 3, and then the final branch on 4. If I go the other way, 1, I got 2, and I got a 3, and I got a 4, right? Oh, it does not matter. The ordering of my carbons doesn't matter because the branches are kind of symmetrical here to where not all of them are closer to one end of the side of the parent chain. So I can pick. It doesn't matter. The name will be the same. So that's carbon 1, 2, 3, 4, 5. Great. So a 5-chain carbon atom is a pentane. We know that we have 3 methyl groups, so it will be a trimethylpentane. The location of those methyl groups are on the 2nd, 3rd, and 4th carbon. So I would call it 2, 3, 4, trimethylpentane. Yay! Amazing. Okay, no alphabetical system there because they are all the same type of a group. Cool. Okay. Yes. All right. I'm getting so excited. This is so ridiculous. All right. Okay. Let's see. I do not trust that this thing in a line is going to give me the most carbons. That is only 5. I feel like I got lots of C's on here. So let's kind of anticipate which would give us the most, but does not give us a branch upon branch situation. 1, 2, 3, 4. Let's keep going. 5, 6. Probably have to come down here. 7, 8, 9. Okay, that looks good. Let's just double check to make sure I don't have any branch upon a branch. And there's no other possible longer thing than 9. There is not. 9 is my longest parent chain. Right? Okay. And let's circle our alkyl branches. Got 1 here. Got 1 here. Oh, an ethyl group. Another ethyl group. A methyl group. Here's a methyl group. Here's an ethyl group. Okay. I got some ethyl groups with 2 carbons in the chain. And I got some methyl groups with 1. I got 3, So triethyl, and I've got 3 methyl, so trimethyl. So I got to put them in alphabetical order. First of all, I'm getting ahead of myself. Let's number this parent chain. Okay, we're going to start carbon number 1 at the end of the chain that's closest to the first branch group that I get to. If I start here, I got 1, 2, 3. I hit something on 3. If I start here, I got 1, 2, 3, 4. Nope, I got to go this way. So this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, this is a non-ane alkane. Non-ane alkane. Okay. So now I'm ready to alphabetically think about the differences in these branches. I've got ethyl groups and I've got methyl groups. Ethyl comes first in the alphabet. E comes before M. So I'm going to tackle my ethyl groups first, all 3 of them, by figuring out what carbons they are on. I have a 3, I have a 6, and I have another 6. So I would call this, oh wait, I'm doing ethyl groups, not methyl groups. Oh my goodness, get it together, Sabodka. Okay, so I'm doing my ethyl groups. I know it's confusing because you're like, why am I naming the guy who has 2 branches or 2 carbons long before this guy? I know, I kind of wish that we named them in order of like the size of the branch, but whatever, that is besides the point. Alphabetical, ethyl comes before. So I've got a 4, I've got a 5, and another 5. So I would call this 4, 5, 5. And there are 3 ethyls, so triethyl. And now I got to tackle my methyls. I got to drop down here. And then I go. My methyl groups, they are on 3 and then 6, 6. So I would go 3, 6, 6, trimethyl. Methyl. Oh my goodness, the letters of the alphabet. So 4, 5, 5 triethyl, 3, 6, 6 trimethyl, and then this root is a non-ane. Yes, look at that. That is so nice and satisfying. Isn't this fun? Like, it looks so scary, but it is like we just figure out the structure, right? By parent chain, numbering our carbons, circling our branch groups, and then blasting out the name. Cool. All right, next one. I betcha I have an idea of where my longest continuous parent chain is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. We got a 10. We got a decane. All right, so there's my decane, and here's my special branch groups. Got some methyls, and I got an ethyl group. Okay, parent chain. If I start here, 1, 2, 3, 4, 5. That's where I get my first guy. Starting over here, 1, 2, 3, 4, 5. Uh-oh, we hit branches on carbon 5 no matter which way we start at. Well, now I got to compare. If one of these carbons had 2 branches and the other one only had 1, then we would start at the side that had the 2 branches, right? But here they both have 2 branches. Well, who's got more significant branches, meaning longer branches out of those 2? This guy, right? So we're going to actually identify, we're going to point to this carbon and say longer branch. I can't spell today. I'm not your English teacher. That's not why you're watching this video. Longer branch situation. Longer branch situation. Yep, we like that. So we're going to start over here on this end as our carbon number 1. 1, 2, 3, 4. So this is carbon 5, 6, 7, 8, 9, 10. So we got a decane. We've figured our numbering system. We're ready to name these alkyl groups. We got different ones. We got methyl group and ethyl group. We know E comes before M in the alphabet, so we're going to name this ethyl group only one of them, so I don't have to say diethyl or triethyl or anything like that. So E looks like he is on the 5th carbon, so I'm going to call him 5 ethyl. I've named all my ethyl groups, all one of them. Now I'm ready for my methyl groups. There are 3, so trimethyl, and where are they? They are on the 5th and 2 of them on the 6th carbon. So I'm going to go 5, 6, 6. Trimethyl. Oh, there we go. You guys cannot see. Trimethyl. And I'm running out of room, so I'm going to have to drop down decane. there will be a lot of grace being given since a lot of these namings are very, very, very long if you need to drop down and make a little bit more space. But something that I'm wanting to see here is that I have commas separating out the numbers if I have more than one type of an alkyl group, and then I have dashes to distinguish the naming category thing for each one of my different alkyl groups. Okay. Cool. So now let's see what it is that we will kind of be responsible for doing on these types of practice problems or naming and drawing these branched alkanes. So here I've given you a name, and I want you to write my structural formula, which a structural formula shows like the carbons and what they're attached to, but it also actually shows a line in between the carbon clusters. My condensed formula is no lines, and it goes straight across as one line from right to left to right. I can read, I promise. Oh my gosh, my English skills are really showing themselves now. Okay, so I get to this word, and I'm like, oh my gosh, okay, there's a lot of information from this name. Whoa! First thing I like to do is I like to be like, how long is the parent chain? Butane. I've got a 4-carbon parent chain here. Then I have some special alkyl groups, some branching groups. It looks like I have a methyl group, specifically on carbon 2, right? We know a methyl group has 1 carbon, or it would look like a CH3 coming off of it. And it looks like I have an ethyl group, right? An ethyl group would look like a CH2, CH3 group. Both of these are on the 2nd carbon. So let's see if we can draw my structural formula. Like, what do I possibly do? Okay, do not freak out. Let's draw the 4 carbons. And we're actually going to, since we're just getting started, give yourself a little bit more space than you think in between the dashes and the letters, because we're going to maybe write some other things in there, like maybe some hydrogens that may be required to saturate the carbons in this parent chain if needed. All right, so first thing is we put the number of C's down that we needed. We said we needed 4 C's. Okay, the next thing we're going to pop on there is our alkyl groups, our branches. We have a methyl group coming off of the 2nd carbon. You're like, well, who is carbon number 2? Guys, you have determined the order here. If you want this to be carbon number 2, then you would put your methyl group off of him. Or carbon number 1, you would put your methyl group off of this carbon number 2. But why do anything weirder? Just say that that's your carbon number 1. You are making this structure. People can look at it frontwards or backwards or whatever. Okay, that was a long tangent, but here's your carbon 1. You have decided that. So he's carbon 2. So I'm going to draw a, let's first by drawing our ethyl group. So our ethyl group's got CH2, or 2 carbons total in it, which means he's going to be a CH2, CH3 group. So here I see my branched ethyl group. Yep. My next alkyl group that I have on here is a methyl group, right? Well, a methyl group, and he is also coming off of carbon number 2. Do I have space? You do have space, because keep in mind, each carbon can make 4 bonds. He's only made 3 bonds so far, so thank goodness we have another bond for him to, yes, make with a methyl group. Okay, so here's our ethyl group, here's our methyl group, both coming off of the 2nd carbon. So we've tackled a butane with 4 parent chain. We have tackled the alkyl groups. Now the remaining thing we have to do is fill in hydrogens on the rest of these carbons. We've got to fill in hydrogens to accommodate for carbon needing 4 bonds. This guy, as written, oh man, he's only got 1 bond. That is no good. Well, he needs to make 3 more bonds, and he will be making those 3 more bonds to 3 hydrogens. So the reason why we left some space here is we go CH3. Yeah. And this should hopefully look familiar. We know that like the ends of these alkanes are always CH3s. Okay, so then I just keep going to each carbon and be like, how many hydrogens do you need? How many hydrogens do you need to make sure that he's bonded to 4 things? So I zip onto this carbon. Y'all, he's already got 4 bonds. No hydrogens for him. He ain't gotten them. Moving over. This guy, he's only got 2 bonds, so he will bond with 2 hydrogens. Yeah? And then finally, my guy at the end, he's only got 1 bond connecting him. He's the end of the chain, so he will be bonded to 3 hydrogens. Okay, we love this. This is fun. All right, condensed formula time. This is a little bit weird. Our condensed formula, well, first of all, our structural formula is what you will get used to drawing in our practice, where basically you will figure out what the root parent chain is, blast off those C's, put in all those alkyl special groups, and then fill in your H's to make sure that everything is saturated. My condensed formula is just going to be everything written in a line. Okay, so the way that we're going to do this is I'm not going to have any dashes, and I'm not going to have anything written above or below my structure. I'm going to write it like this. That's CH3, CH3. The next thing I see is a carbon, C. But he is attached to things, even though I'm not writing CH something, he's attached to an ethyl group and a methyl group. So if there's something branched off of a carbon, I'm just going to, in parentheses, after that specific carbon, write what they are. I've got an ethyl group, CH2, CH3, and I've got a methyl group, CH3. So what we've just represented here is we've got the side branches in parentheses. Yep. So if you see something in parentheses, that just means that the things in parentheses are coming off of the carbon that is written before it. Cool, so CH3, C with all that stuff on it. We're ready to move on to the next guy in the parent chain. He is a simple CH2. And then the last guy is a CH3. So that is a significant amount of weird branches coming off of that second carbon. Okay, so that's our first example on 2-ethyl, 2-methyl butane. Going on to the next example, we got a 3-ethyl, 4-propyl heptane is what I'm zoning in first. Heptane means I have 7 carbons in my parent chain. So let's go ahead and put those in there. Once again, maybe leaving a little bit of space for you to fill in my hydrogens. Let's see, hopefully I won't go too crazy like I have done in the past by, let's see, it's 6. That should be okay. Okay, so there's my 7 carbons. I'm like, okay, what you got going on here, carbons? What side branches do we have? Looks like we have an ethyl group on the 3rd carbon. 1, 2, 3. An ethyl group's got 2 carbons in the chain. So that would be a CH2, CH3 situation, right? And then I've got a propyl group on the 4th carbon. So 1, 2, 3, 4. A propyl means I'm going to have 3 carbons. And if I have a chain of 3 carbons all chained together, that first carbon's only going to have 2 hydrogens. And the next carbon still is only going to have 2 hydrogens. Remember, my carbons at the end of these branches are the only ones who have 3. Everybody else is going to be CH2. So 1, 2, 3. Yes, that's 3. So that's a propyl group. Cool. That looks great. Now I've got to fill in my hydrogens. This guy gets 3 hydrogens. Oh, my 3 looks terrible. 3. This guy gets 2 hydrogens. This guy, he's got 1, 2, 3 bonds. He needs 1 more, so he gets 1 hydrogen. So I have a CH right there. This guy, same thing. He has 3 bonds to him, so I'm going to give him a hydrogen. This guy, he needs 2 hydrogens. This guy needs 2 hydrogens, and then my guy at the end is a CH3. And if you want, you can go back and make your lines a little bit more friendly visually. I do not care. Nice. That looks beautiful. Now we're going to condense it down with the thing where we do in parentheses showing if we have anything branching off of these parent chain carbons. I think this is going to be very long, so I may have to make this a drop down more than 1 line. That is okay. So our first guy in our parent chain is CH3. Our second guy in our parent chain is CH2. Our third guy in our parent chain is CH. I'm getting ready to tell you why it's only CH, because I got something on him, a branch, which is a ethyl group, a CH2, CH3. Yep. Moving on to the next guy, CH. What does he have going off of him? Open parentheses. Here we go. CH2, CH2, CH3, close parentheses. This is where I'm going to have to drop down to finish my structure. So the rest of it is CH2, and then a CH2, and then a CH3. None of these have any parentheses next to them because they don't have anything branching off of them. Yep, condensed formula. Yes. Last example. I'm getting excited. Okay. So we have blah, 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 blah. Hexane is what I'm zoning on. I can do that first. 6 carbons. We love this. Okay. So let's draw 6 C's in a row. Yep. Okay. Now what special groups do I have coming on here? I have methyl groups and I have 4 of them. Okay. What carbons are they on? I have one on carbon 2 in a methyl group. Me, eat peanut butter, me, has only 1 carbon. I also have a second one on the second carbon. Then I have one on the 4th carbon. And then I have one on the, wait, I did not draw enough carbons, you guys. Get it together. Okay. And then I have one on the 5th carbon. And y'all, it does not matter whether you put the branch groups up or down. We know that these are all covalent compounds. So each time I see a 4-bond situation, it's not just like a cross. We know that that's going to create a tetrahedral Vesper shape on every single one of these things. So you're going to get something way more 3D that is not even going to look like anything like that, no matter how much you think about, well, what makes the most sense to put something above or below? It does not matter. You know, it is that. This is a 2D structure here that is not going to really represent what the structure looks like in real life. All right, so yep, we got all my groups on there, right? We had 4 methyl groups, the tetramethyl situation. Now I got to fill in my hydrogens. This guy, he's got a CH3. Nope, we're good. He's got all 4 bonds. This guy's going to require a CH2. This guy, he needs something else. He needs a hydrogen. Also, this guy, he needs something else. He needs a hydrogen. And then finally, my guy at the end is going to be a CH3. Okay, now here's something fun here. I'm going to start naming my condensed formula. Obviously, this one is easy, so we will go CH3. Moving on to the next guy, a C. Here's something fun. There is a possibility for you to do open parentheses CH3 close, open parentheses CH3 close, but I have 2 of the exact same group on the exact same carbon. So a possibility for you, if you would like to, is to go CH3 and then you're going to put a 2. I'm just saying, hey, there are 2 of those groups coming off of that carbon right there. Okay, let's see. Next guy. Next guy, we have a CH2. Then we have a CH. He's got a branch. He's got a CH3 branch. Next guy is a CH. Ooh, I wrote a dash in there. I got too excited. Sorry. The next guy is a CH group coming behind him. He's got a branch, right? He's got a CH3. Will I have enough space? Will I have enough space? Yes. And then my last guy is CH3. So this is a condensed formula for this structural formula that we've drawn here of 2,2,4,5 tetramethylhexane. Okay, and one thing that was new in this example that we have not talked about before is I can, if I have 2 of the exact same branch groups coming off of the same carbon, I can just represent that as, hey, a 2 on the outside of whatever that branch is to tell you you have 2 of the same kind of branch. All right. So y'all, look at what we have just done, and hopefully that wasn't too scary. It's just, you know, it's like putting a puzzle piece together. So this is our lesson on naming branched alkanes, and next time we're going to take it one more step further, which I'm very excited about.